Hello everyone, today we'll be learning how to get a list of all files in a directory with Python. So most of you might be working with Python and there are cases when you actually need a list of files to iterate over it, and we'll be learning how to do all stuff in Python. So today the path we'll be following is how to get the list of files and folder, some recursive method. We will use the method of rgglobe and then using globe with conditional listing, and after that we'll doing one of the most important tasks, which is opting out of listing junk directories. So let's get started. But the first question that might come to your mind is, come on, I have os.list dir, why do I need something else like pathlib? Why do I need it if I have os.list dir? So there is absolutely no problem with os, but the one thing that I actually find very problematic is that it returns the path as a string. Now, since you're having a string, when you're working with different operating system, for example, in Windows, you're having a backslash for path, while in Mac OS or Linux, you're having forward slash for path. Now, for such cases, you need to do some string manipulation and something in order to actually let the platform understand what you are doing, or you might need to add some raw string or something, but it gets actually trickier when you are doing such stuff for different platform. So that's where our pathlib, and not only this functionality, various other functionality comes with pathlib. So let's just directly go to VS Code and understand how these things are happening. So let's get started with the coding stuff. So right now I'm using Visual Studio Code and in the Jupyter Notebook. So Jupyter Notebook is basically used for data science purpose, to execute each line of code so that I can explain every line. But you can execute the code in your whatever text editor you are using. It will work perfectly fine. So for this tutorial I have made this directory which contains one subdirectory and file1, file2 and get this.py file, and the subdirectory again contains a file3 under it. So let's get started. The first thing we need to do is to import the library which is called pathlib, and then I will make an object named desktop which is going to be a pathlib.path object, and over here I will pass the address of the directory. So since I'm going to do experiment with this directory, so I will be giving the path of this directory. So either you can take in this way or you can just copy the relative path and paste it over here. Since it is exactly same, so there is no difference. So now my desktop object has been created, so I can just see what type of object is this. So it is a window path, and it contains the path or to that directory. So since the path to the directory is directory itself, so it shows directory. Since I'm using Windows right now, so it is showing me Windows path. If I were using Linux or Mac OS, then it would have shown me other file type and not window path, or that would have been different for different operating system. For example, it would have been like, I'm sorry for the spelling, it should be POSIX path, and then the path for a directory would be written over here. Yeah. So it would have been the case if you were using Linux or Mac OS. Since I'm using a Windows path, so here it is how it looks like. So now I'm having a desktop. So what I would like to do over here is to create a generator so that I can iterate over it. So to make it a generator, I can just pass it over with this function itrdir. So now I'm having a generator. So either you can use this or you can just give an object to this. Let's say path name something. So right now I'm not doing this. I will just be iterating over it with this complete name as desktop.itrdir. Okay, so after this, since I'm having a generator, so I can directly get a list out of it. So for this I need to just call this list class, and here I will pass this generator, and I will get the list of all the items. See, I was having file1, file2 and get this.py, all this stuff over here, and the directory as subdirectory. Perfect. this is what I wanted, and now I'm getting a list. You can do this way, or if you just want to iterate over it, you can use a for loop for this. So how to use a for loop is like this: for item in desktop dot itrdr, and this is the same way you usually use a generator. So you just iterate over the generator, and from here you can just print the stuff. So I just want to know what are my items. So I will just do this, and yeah, now I'm getting all the file path of every item. But what if I want to know whether I want to know if the file is a file or it is a directory. So for that, the Pathlib actually provides us a functionality that can be written in this way. I'll explain the code just in a while. Let me let it hold. So print directory, or I will use single inverted comma directory if item is directory, else print file. So what this code is actually doing is, first of all, this is a format string. So whatever stuff is inside this curly bracket is supposed to be an object, and it's not going to be part of this string. So basically this item is not an item in string, but is the item over here. So and then it is executing this statement that says print directory if the item is directory. Okay, so this is a function. I should be using a bracket over here. So you can see over here that is dir is a function that returns a bool type object. So if it is true, if the item is a directory, then it will return dir, otherwise it will return file. So you can see it will print the item name, and then it will print whether it is a directory or a file. So let's execute this code, and you can see the file1 is a file, file2 is a file, and get this.py is also a file, while the subdirectory is a dir, so that's why it prints dir. If in case I only want to get all the files from a directory, not the subdirectory, so I can use is file function. Let me just show you an example how to do this. For item in desktop dot itrdr, and then if the item is a file, see, so if this is true, if the item is file, then just print the name of the item, and see all the files have been printed. See how it has skipped the directory over here. So this is actually a very cool way to iterate over the file. I have been in competition, and there I actually needed only some files. I needed to get some file. So if I initially I used to do stuff like if the file name ends with this, then do this. So it actually provides a very nice functionality. So I can just directly use this and get my work done. And since I'm having a for loop and it is a generator, so I can also use the list comprehension trick over here. So I will just say I am having an object items, which is basically a list that contains item which I get while iterating over desktop.itrdr. Okay, it's if the item is a file. See, okay, so some of the mistake that I have often faced is not using it as a method. And see, the thing I get is actually this, like the items over here looks like this. If I would have used it as a function, then there is absolutely no difference over here, because the function has been called automatically. So very nice. The next thing that I want to tell over here is about recursive listing using rglobe. So basically this is a function in this Pathlib. So why is this important? So consider this thing. Directory is like a tree. So in a tree you're having some branches, then it's split into more branches, it branches off till the leaf. So directory is like that. So directory has some directory and some subdirectory, and it has files at the very end. So in these cases you can see I'm printing the only the file1, file2, and okay, let's get over here. Yeah, the file1 is printing, get this.py file is getting printed. But what if I want to know the stuff which is inside subdirectory? How will I do that? So I can do this by using a recursive method. So to recursively list the item in directory means to list not only the directory's content but also the content of the subdirectories, their subdirectories, and so on. So with Pathlib, it is surprisingly easy to recurse through a directory. So you can just use this function, and let me just show you how to do this. So I'll just use rgglobe. I'll pass an argument of asterisk or a star over here. So this is basically a wildcard which is used for globe pattern. So when I do this, I'll get a generator object once again. Since now I'm having a generator object, I will just get the list of all the items inside this generator using rg globe, or there's a better method is just to get object out of this. So I will just call it as most of the time I call it container. I don't know why, so I just call it container, and over here I will get the list out of container. And see, I'm getting the file1, file2, get this.py subdirectory, and the file inside the subdirectory. See how cool it is. So there are many times when you don't want all the files. You want files that are just of txt type, or they are following some certain pattern. So the method which are related to our globe are very comes into picture for this. So what we do use is actually wildcard. Over here you can see the globe pattern and what type of item it matches to. So for example, if you are using star, then you will get every item out of that directory. If you are using star.txt, then this means all the item that ends with txt, say notes.txt or hello.txt, will be returned. If you are using a 6 question marks over here, so this is actually a question mark. So if you are using 6 question mark, then all the files or all the files that are having 6 characters, as long as it does not matter if the extension is included or not. So over here you can see 01.txt, there are total 6 letters. It does not count only 01, it counts the whole all the character inside the file name. Or a, for example, a-01.c or .zs HRC. So over here you can see all the 6 characters will be written if you're using 6 question marks. If you're using a star, then all the files that start with the name a is returned. If you're using this type of statement like ABC, ABC, and ABC all enclosed in square brackets, then it returns every item whose name is 3 character long but only composed of characters like A, B, and C, such as ABC, A, C, B. Uh, the permutation actually does not matter over here. Also, one more thing that I actually face most of the time is that in Windows the paths are actually case insensitive, while in the Unix system like the Linux or Mac OS, the paths are case sensitive, case insensitive, so you need to take care of that. So right now we just understood the various patterns using wildcard. So we just saw that we can do something using this star wildcard, but the same stuff can be done by just using iter method. What sets the globe method apart? So the thing is pattern recognition over here. So let me just create a desktop object once again, and for this time I'll pass another directory path which is over here. I just created it. So I'll just copy the path and paste it here. Yeah, okay, the path was obviously same. So now I will get desktop and I'll just show what type of object it is. It's a window path object, no difference at all. So what if I want to get all the files inside it which ends with txt? Right over here you can see todo.txt. So what I'll do, I'll say I want a list of all the files which are in this desktop. I'll use the globe method to make this a generator, then I'll pass this argument star.txt. So all the file that ends with this are actually going to come. So you can see there was only one file 2.txt and I received this. Whoa, that's quite amazing. And again, one thing I want to remind you is that since I'm using Windows, so I might do something like which is case insensitive, but in the case of Linux and Mac OS, which are Unix based operating system, they are case sensitive, so you need to take care of that. Another thing, let us say that you want a folder all the files which are inside this real Python. So you can see there are two MD files. So what I'm going to do, how to get all this thing? So I'll just say list of what? List of all the file which is inside this real Python, and I'll give this a / and one star and enter. You see all the files I'm getting. This tic-tac-toe.md, then iterate.iterate.dict.md. So how cool it is so to get all this thing. The same thing you can do using the rg. So I basically call it rg, I don't know why. So if you want the list of all the item which is inside this desktop, I will just use our globe method and all the files that are ending with md. So you see how cool it is. It is going inside this desktop, then it is going inside the script also, not script, is real Python to get all these md files, and then it is going inside this notes file to get a file with this name. So the rg globes provide you this. So with globe you cannot do this. Okay, let me just actually show you. So had been the case like if I just use globe over here, so it was not possible for me to do. Let me just do this and show you. See, it is returning me an empty list, so it is possible when I'm using R globe. Okay, so I think you got the very idea of this R globe and globe only. And guess what, you can actually use the globe method and get it to behave in the same way as R globe by adjusting the globe pattern passed in an argument. So what I can do is just get a list out of desktop.globe, and over here I'll pass ****.md, and see I'm getting. So you remember when I did this only globe, I was getting nothing, but when I did this, I'm getting all the files with ending with md, which has the extension type md basically. So when I'm using this, it actually shows yeah, just go inside the folder and search for the md file. This is what it's saying, and that's how you can just make it. So over here you might have understood that this thing, the globe passed with argument like ***** is equivalent to, I don't know if this is equivalent sign or not, but just get the point that it is equivalent to our globe star. I hope you get this idea right. Now, one of the potential drawbacks of the globe method is that you can only select file based on globe patterns. So if you want to do some advanced matching or filtering on the attribute of an item, then you need to reach for something extra. So there are basically three methods through which you can do this. One by using a for loop, or you can just use lit comprehension with a conditional statement, or you can use a built-in filter method. So let's actually explore how these things are done. So first I will show you, you can see my desktop is already there, it is a window path. So I'll just make a for loop for item in desktop.rglobe, and I'll ask it to get all my files, then I'll ask if the item is a file. If the item is a file, then just print me the item. And see, it is giving me all the files over here. So it is giving me all the files that is present inside this desktop directory. The same thing I can do using a list comprehension. Let us say I'm creating an object name item list object, and I'll just say git store item, which was generated when I was trading in desktop.rglobe. I'm really sorry, it was a dot. I'll ask it to use a wildcard, and if item is a file, not FIFO, it's a file, and see, now I'm having all the thing, and see, it is exactly the same. The difference is over here you were seeing the items, which are basically Windows path over here, and here I'm getting all the objects as window path. See, the other method that you can use is by using a filter method. So how it's going to look like is this: I want a list. After applying filter over a lambda function, I hope you are quite familiar with the lambda function. So in the lambda function, I'm passing a parameter as item, and the function that it is happening is that if the item is a file, and it's desktop dot again our globe, same thing, no difference. And now this is going to return me all the files once again. So what this actually is happening is that this lambda function is basically checking if the item is a file through this generator. Over here we are applying the filter using this filter method, and then we are passing this to this list class to get the list. And see how simple it was. So this actually gives you idea about how flexible, how versatile all these globe method. But in case of very large directories, they can be a bit slow. So in the next section, you will be examining an example which reaching for more control over iteration with ITER may be a better choice when I can use this. Now let's say you want to find all the files on your system, but you have various subdirectories that have lots of subdirectories and file. And there are many subdirectories in which you are really not interested because they contain some temporary files and all things. So let us say that I'm having a directory like this. So over here, if you see it more clearly, let me use a laser. So things like this actually denotes that there are so many files that it cannot be displayed. These three dots uh, denotes this. So if there are so many files, so there are files like you are not interested in file, let us say inside this directory or in temporary files. And generally these types of file which are of no interest are called a temp like this, or the temporary files, or sometimes it's called log. What makes it worse is that they are everywhere and can be at any level of nesting. The good news is that you don't have to list them, as you will learn next in this session. And let's go to VS Code editor now. So you just come to know that there are some files with the name of temps, temporary file, or logs, which we are actually not interested in. So the most obvious thing that comes to the mind is that I'll make a list of a directory with the name, let's say script dirs, sorry, list, and it will contain file names. Like I want to skim with file name that is named as this, and temporary files. Sorry, temporary files, and then a file with the name of logs. So this is the most obvious thing, but uh, so what you are going to do is to use now rglobe function. Here you might need to consider something very important. Let's go into this large directory file, and let me go in documents, let's go inside this notes. I just want a random file. So you can see there are so many files. Let's go into, and let me just copy this path. Okay, and let me paste it. Now look at this thing very carefully. Even though I'm having a path like this, I'm obviously not interested in this directory. But since the name is just zero, the name would be just 0.txt. It is not going to match any of the items in skip dirs. So you need to check the whole path for the block name, right? So here is where one thing's come into picture. The pathlib provides you a .part attribute which contains a tuple of all the elements in the path. Let me just show you how it's done. So let's say I'm having an object with name temp file, which is basically a pathlib with path, and it contains this path as an argument. So okay, you might have noticed that these are some escape characters, so I'll just use a raw string over here, print it. Now what I want is temp file dot parts, and you see it is returning me a tuple with all the parts, this large directory, documents, notes, temp, tools, and 0 points. Now what I can do with this, all you need to do is to check that if any of the element in this dot part tuple is in the list of directory to be skipped. So how you can do this, we can take the advantage of sets over here. So how can I use sets for this case? So there is a function called is disjoint method, and I can use it to determine whether it is intersecting, the elements are intersecting for both these sets or not. So how it's done, let me just tell you. So let's say there is one set which has elements like document and notes, and the other is like find me.txt. I will just call this function of disjoint and pass the second set, which is going to be like temp and temporary. So you can see there is no element which are intersecting in both these sets. So what do you think is going to be returned? It is going to be returned as true, because obviously it is disjoint. Disjoint means there is no intersection. If the case was not like that, if instead of this temp it was document, so it will return me false, because there is one element which is intersecting for both these sets. So what I can do, I can simply for this skip dir list, I will pass it in the disjoint while iterating in the directory. So how this is going to be done, so let us say I'm making this large dir as a pathlib object which is having path, and then let's say large dir. Now I'm having a method. I will just iterate in for item in large dir dot idr, or I will better use our globe over here. Use a wildcard of this, not 8, it's asterisk, and I'll say if the set of items, item dot parts, that is the item dot parts is returning me this tuple, and I'm converting this tuple to set, and now I'm asking if it is disjoint, is disjoint with what, with skip dirs. If the case is like that, then I will just print the items. Let's go, and yo, so if I just show you this large directory over here, so I will show you. So this contains documents has these files, and then inside notes. Okay, see in this temp folder there are so many files over here, but this piece of code just skipped this temporary folder because of this comparison over here. So this makes my life so much easier. So now to check if the pass is one of the unwanted folder, you can cast item dot parts to a set and then use is disjoint to check if skip drs and parts do not have any items in common. If that's the case, then the item gets printed. Actually, the same thing can be implemented using a filter function. Let me just show you how. So you can just uh, call a list class and then use the filter method. Inside this filter method, I'm going to use a lambda function. The argument to that is going to be an item, and the function that it is going to perform, this lambda function basically, is lambda dot parts. It will look if this is disjoint with the set that is skip dirs. Basically it's a list, but yeah, we can compare this. And the generator over here is the large dir dot r globe, and check for all the elements. And yo, we're having a list of all these documents which are not in the temporary or the temp file. So this is how we do all these things. Let us say you are working in a company and you have to do some stuff like this. You are supposed to just work all with these images, not in the temporary file, but the files which are not in the temporary file, basically. Yeah, the same thing. So you can use this functionality to perform those actions. Now let's actually do one thing. Let us try to create a whole function out of let us try to create a whole Python out of this, and let's execute this in a while. So now here I have created a module which I have defined with this script directories and this generator function. So what this does is it contains the name of directories that I like to ignore, and then I have defined this generator function that uses this itr dir to go over each of them. The generator function uses this type annotation dot pathlib path to show that the first argument is a path and not any string that you might just path while calling this function. And then the exclude is having this script directories over here, so you can just edit it and it will compare all the files which are not supposed to be, which are supposed to be skipped. I'm sorry. So how this function works is if the item name is in the exclude list, then you will just move on to the next item, skipping the whole subdirectory tree in one go. If the item isn't in the list, then you will yield the item, and if it's a directory, you invoke the function again on that directory that is within the function body. The function conditionally invokes the same function again. So this is the hallmark of recursive function. That's how recursive function works, right? Now this recursive function effectively yields all the files and directories you want, excluding all that you are not interested in. So let's run this module right now. So how I can run this is, first of all, I will import my module, and then I'll import the module that I just made, skip dirs, and then I'll make this large directory which have a function like this. Yeah, fine, and skip dirs. I think it should, yeah, it is working obviously. Now I want to get the list of all items by applying the function in this skip dirs of get all items and then the directory over which you want to iterate. And magic, yeah, obviously it's not a magic. So this is how you get all these items. So over here this function calls each uh, each time it is calling itself when it finds a new subdirectory in which you are interested. Otherwise it just skips the all the files which are in this skip dirs, the directory which are in this skip directories. So this is how you do all these things. So in this case, using ITDIR is going to be far more efficient than the equivalent globe method. In fact, you will be using ITDIR in generally more efficient than the globe method if you need to filter on anything more complex that can be achieved with a globe pattern. However, if you need, all you need to do is to get a list of all txt files recursively, then globe function is faster, obviously. So I hope that this tutorial has provided you some values and understanding about this pathlib directory, and you will be able to do the work faster after this tutorial. So thank you so much.